The Intelligent Rescheduling System is a module within the Movement Control Unit that uses a rules database to solve problems caused by operational disruptions. The rules are designed to be maintained by an airline without needing the system to be rebuilt. They are written in a fourth-generation language that looks a little bit like SQL, but it specifies actions to take in response to problems. A more detailed description is provided in the IRS info file that is installed as part of the FASS system. We will have a look at it now. You can see an example instruction here. It tells the IRS solving engine to select a given activity, in this case the activity that is the subject of the problem being solved, and move it to a new aircraft. The where clause identifies candidate destination aircraft based on a set of criteria. In this sample case, we want the destination to have a gap being big enough to accommodate the flight, to have enough seats to accommodate the passengers, and to not cause any new constraint violations for the sector and airports. An instruction like that would be attached to a particular problem type in the rules database. The IRS info file also specifies the entire IRS grammar so you can extend the rules or modify them over time. As I said, an instruction like the example we have just looked at is attached to a particular problem type in the rules database. The rules database is a simple text file, irs.kb, that can be maintained by an airline to capture their personalized knowledge of problem solving over time. You can see some sample rules on the screen now. The first section is a set of rules for attempting to solve geographic disconnections in the schedule. Such problems might arise from flight cancellations. Each action part specifies a candidate action to take in resolution of the header problem type. So that is the language that drives the IRS. What happens inside the IRS is that it explores a whole search space, a tree, using the action specified by the rules. Each action engenders a new state. You can think of each state as a chart with a string of actions applied to it, with both solved and maybe new problems in it. The IRS engine uses evaluation criteria to decide which branches to continue following and which ones to truncate because they don't look promising. To use the IRS in a demonstration situation, we are going to set some parameters that one might not normally use in a production environment. Firstly, we're going to change the objective function by which we evaluate the quality of a state from passenger inconvenience to flight problems. We do that because we generally don't have any passenger loads on the flights, so using passengers as a criterion directs the solver down false solution paths. Because there are no passengers, all solutions look equally good to it. We want to direct it to follow paths that solve the most problems. We could also do that in production, but it would be more usual to direct the solver to find passenger-oriented solutions by preference. We are also going to tell the solver to exclude maintenance expiry validations. This is because in the demonstration environment, the aircraft are out of hours and cycles on almost all check types. There is also only one way to solve an expiry. You have to add the required maintenance. But because there are so many missing checks in cascading hierarchies of supersedence, there is no reasonable way to solve them using normal actions. In a production setting, selected maintenance checks might sometimes expire early because of schedule disruptions, but they are rare and they are not packed on top of one another. Another thing we're going to do in the demonstration setting is remove the IRS engine's ability to cancel flights. We do that because there are no passenger loads. Without any passengers, cancelling flights is a first choice action to take. You don't want to delay or move an empty flight. You would rather just not operate it at all. So for demonstration purposes, we will disallow those actions. But in a production setting, they would be unfavorable actions anyway because of the passenger cost. We would generally not need to disable cancellations in a production environment. Lastly, we are going to select a small subset of all the problems. The reason we're doing that is that there are some problems in the set that arise from the use of test data rather than production data. One such case are airport equipment requirements. There are simply no rules in the database to tell IRS how to solve such problems. We could make up some rules, but at this time there are none. As you can see, attempting to solve one simply results in a no solution state. So, we select a set of ground time problems and some maintenance expiries and start the engine running.